In this episode, we're going to take a topic that sounds formal and maybe a little abstract and connect it directly to something very real in automation, knowing what you can safely deploy. When teams release automation code, they need a clear way to communicate what changed and how risky that change might be for the people and systems that depend on it. Without a shared language for releases, you end up with vague statements like it should still work or nothing major changed, and those statements are not reliable enough for systems that run unattended. Semantic versioning is a simple, structured way to label releases so that the version number itself communicates meaning. It helps beginners because it creates a predictable rule set for naming progress, and it helps teams because it creates a shared expectation about compatibility. When you understand semantic versioning, you can look at a release number and make a smarter guess about whether updating is likely to be safe. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Semantic versioning usually follows a three-part pattern that looks like numbers separated by dots. Each part carries a specific meaning about the type of change that was made, not about how big the code base is or how long the team worked on it. The most important idea is that the version is a promise to the people using the automation, including other teams, pipelines, and even your future self. That promise is about whether the release remains compatible with what came before. Compatibility, in this context, means that things that relied on the previous release will keep working without needing changes. Automation often sits inside larger workflows, so compatibility is not optional. It is what prevents surprise failures in the middle of a deployment window or scheduled job run. Semantic versioning makes compatibility visible by putting it into the version number, which is a lightweight signal that travels with the code. The three parts are often described as major, minor, and patch, and while you do not need to memorize labels to benefit, you do need to understand their intent. A patch release is meant to be the safest kind of update, typically a bug fix or small internal improvement that does not change expected behavior for users. A minor release is a step that adds functionality in a backward-compatible way, meaning new features appear but existing usage still works. A major release is the warning label. It signals that something changed in a way that can break existing users, such as removing a feature, changing defaults, or altering interfaces. In automation, those categories map neatly to operational risk. Patch changes are usually low risk, minor changes are moderate risk that still should be tested, and major changes demand a careful review because they may require coordinated updates to whatever depends on the automation. To make this concrete, imagine automation as a service with a contract, even if it is just a script in a repository. The contract might be the expected inputs, the expected outputs, the locations it reads or writes, the behavior it performs, and the error signals it produces. If you change the contract, you risk breaking the things that call it. Semantic versioning is how you reflect contract changes in the release number. If you fix a bug but the contract stays the same, you bump the patch portion because you improve correctness without changing expectations. If you add a new option or capability without breaking existing usage, you bump the minor portion because the contract expanded but did not change for existing users. If you remove or change something that users relied on, you bump the major portion because the contract changed and users may have to adjust. This contract thinking is crucial for deployable automation because automation is often embedded, and embedded things are hardest to change quickly when something breaks. Beginners sometimes assume a version number is just a counter, but semantic versioning is closer to a communication tool. It is a shorthand that helps people make decisions when they do not have time to read every change. When operations teams decide whether to update automation before a critical run, they need a risk signal that is faster than reading code. The semantic version number helps by summarizing intent, and that intent becomes more trustworthy when the team applies the rules consistently. Consistency is what builds confidence. If you learn that patch releases are truly non-breaking, you can update with less fear. If you learn that major releases are truly breaking, you can plan upgrade work rather than discovering breakage in production. Semantic versioning turns release numbers into operational information, not just project decoration. It also helps to understand that semantic versioning is not primarily about the size of a change in lines of code. A tiny change can be a major release if it breaks compatibility, and a large change can be a patch release if it only fixes internal issues without altering the contract. This is a mindset shift for beginners because it teaches you to evaluate changes by impact, not by effort. In automation, impact is the real measure because the code exists to run reliably in an ecosystem of other systems. If you rename an input file location, that might be a one-line change, but it could break every pipeline that expects the old location, so it deserves a major version bump. If you fix a rare bug in retry logic that does not change inputs or outputs, that might be many lines of code but still fit as a patch. Semantic versioning pushes you toward thinking about who depends on your automation and what they expect. Another reason semantic versioning matters is that it supports coordination across distributed teams. When different teams build on shared automation components, they need a stable way to say we are using version X and we can upgrade to version Y safely. Without that shared labeling, coordination turns into constant meetings and uncertainty. A clear versioning scheme reduces negotiation because it encodes risk expectations. That is especially important when a team cannot upgrade immediately, maybe due to a frozen production window or regulatory constraints. If semantic versioning is applied correctly, a team might feel comfortable taking a patch upgrade even in a restricted window, while deferring a major upgrade until they can plan and test. That ability to differentiate upgrade types is a practical operational benefit, not an academic one. Semantic versioning also interacts with the idea of dependency management, because many automation projects rely on libraries and components that have their own versions. When your automation depends on a library, you are trusting that the library's version number means what it claims to mean. If a library follows semantic versioning, then you can often assume that patch updates are safe and that major updates require more care. That assumption is not perfect, but it is a useful guideline when applied with testing and caution. The same logic applies in reverse. Other projects might depend on your automation code, so your versioning choices affect how safely others can update. When you apply semantic versioning, you are not only labeling your own releases, you are contributing to a more stable ecosystem. That stability makes automation more deployable because deployments are about coordinating change, not eliminating change. A common beginner misconception is that semantic versioning guarantees nothing will go wrong, but it is not a magic shield. It is a communication framework, and its value depends on people using it honestly and consistently. Even a patch release can contain a bug, and even a minor release can have unexpected side effects. The difference is that semantic versioning gives you a disciplined way to describe intent and expected compatibility, which improves planning and reduces surprise. It also makes it easier to talk about problems when they happen. If a patch release breaks compatibility, that is a signal that the release process failed to detect a breaking change or that the team misclassified the change. Having that language helps teams improve because they can discuss classification errors clearly. Over time, a team that uses semantic versioning well becomes better at understanding its own impact. It's also worth noting that semantic versioning encourages better release habits, because it forces you to think about what constitutes a breaking change. That question pushes you to define interfaces and expectations more clearly. In automation, the interface might be a configuration file format, an environment variable, an expected folder structure, or the behavior of error handling. When you know you will have to label a breaking change as major, you may decide to avoid breaking changes by designing for backward compatibility, such as supporting old and new formats for a transition period. This kind of thinking makes automation more stable because it reduces abrupt shifts. Beginners benefit because it encourages thoughtful design even before they have years of experience. Semantic versioning is like training wheels for impact-aware engineering. To bring it all together, applying semantic versioning means using release numbers as a structured promise about risk and compatibility. Patch releases communicate safe fixes, minor releases communicate compatible growth, and major releases communicate breaking change that requires attention. The goal is not to make version numbers look professional. It is to make them useful as operational signals. When automation is deployed repeatedly, often without direct supervision, those signals help teams plan upgrades, reduce incidents, and coordinate across distributed work. Semantic versioning becomes a shared language that turns change into something manageable rather than unpredictable. If you can apply that language consistently, you help your future deployments stay calm, because you are giving everyone a clear clue about what kind of change they are about to accept.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.